going to be costing you battery power now.
Okay, so that's the continuation of our EIGRP 7.2, configuring EIGRP for IPv4. So that's our topic of discussion for today. The topology which I will use to show how we configure our EIGRP is as shown in this slide. So we have a R1, R2 and R3. They are connected. It's a kind of a triangle. And R2 is also connected to ISP. R1 has a 172.16.1.0 network, 172.3.0 and 10.4/30 network is between R1 and R3. And the bandwidths of those WAN links, 64 kilobits, 1024 kilobits and 1544 kilobits are also mentioned. So this whole router, the topology of R1, R2 and R3, we call it as a one EIGRP routing domain. Okay, and how we do the configuration, we start with the command router EIGRP. So that command will enable the EIGRP process on the router, on each router. And then after that we use a number which is called autonomous system number. This number is of a local significance. Okay, so this number should be same on all routers which we want to make or we want to enable EIGRP on, and it should be same number. It should be same in one routing domain. This autonomous system number is not that number which is used by some external routing protocol like BGP or EBGP for the identification of any organization, because IANA assigns a single autonomous system number to a single ISP. So it is not that number. It's different from that. It is only locally significant. So in this particular configuration, you can see that we can use EIGRP1 as autonomous system number, and one more thing in EIGRP configuration is a router ID. Router ID is the name of that router. It looks like a IPv4 address, but it is not that IPv4 address, so don't confuse it. It's just a ID, a name which we give to the router. In EIGRP, it is not that important, but OSPF, as we have discussed already, that it has more significance. But it's better, it is recommended to give a router ID in EIGRP process as well. But again, if we don't give it, it will take. So there are two conditions. First, it will look at the loopback interfaces. Highest active loopback interface will be taken as a router ID. And if loopback interfaces are not configured, then highest active interface, IPv4 address, that will be taken as a router ID. But it is good, especially when we are doing some troubleshooting, it will help us. So with the help of this router ID command, we can assign a router ID to the EIGRP process or EIGRP router. So we can use this EIGRP router ID and then a IPv4 address. How we configure it? We use after that a network command, as you can see over here in the slide. In our case, router EIGRP first command with the autonomous system number 1, and then give a command network 172.16.0.0. Now we are adding the whole big network into the process of EIGRP. If you look at the topology, it contains 172.16.1.0 network as a LAN interface and a serial interface as a 172.16.3.0 network. So both of those networks will be covered, will be added, both of those subnets will be added by giving this only one command, network 172.16.0.0. Now it has the advantage that we are only putting one line of the configuration. That is one obvious advantage, but it has a problem and disadvantage as well. The disadvantage is that if any other interface it comes under is configured with the same with the IP address, a subnet IP address which is covered by this network address, then it will automatically be added into EIGRP process and EIGRP will be enabled on it.
No welcome mat.
Which is no good. Yeah. So for that purpose, in order to cater for this particular problem, we have a solution and it is called wildcard mask. Wildcard mask is just a inverse of a subnet mask. As you can see, that whatever the subnet mask is, we take 255, 255, 255, 255 and subtract that subnet mask and the resultant is our wildcard mask. If your subnet mask is 255, 255, 255 or 252, then the wildcard mask will be 0 here, 0 here, 0 here and 3 here. So solution of that problem is that we use wildcard mask to configure our network command. So in this case, what will happen? I will put a network 172.16.3.0 and then wildcard mask 0.0.0.3. And accordingly, for the other LAN network command, for LAN interface, I have a network 192.168.10.0 and the mask is 255.255.255.0. So its wildcard mask will become 0.0.0.255. Alright, so this is the simple way, and it's simple way to configure our EIGRP. Router, EIGRP, autonomous system number, and then network commands, network, and then wildcard mask. We use passive interface command, as we have already discussed in our OSPF, that the passive interface command, what this passive interface command is doing for us, it prevents neighbor adjacencies. We give on the LAN interfaces this command, so that those messages which are being used, hello messages and updates, they are not sent towards that LAN interface. That it may happen that somebody brings its own rogue, we call it rogue, routing device, and then it connects over there, and then it receives those messages, and through those messages he can get the idea of a network. So we suppress those messages, okay, any update traffic, with the help of this command. And how this passive interface command is given: router, as you can see on the slide, router EIGRP autonomous system number, and then after that passive interface. And in our cases, especially in the lab environment, in most of the cases, it will be our gig 00 interface or gig 01 interface. So after that passive interface, put that interface type and number. Okay. So any question about the configuration? No. Show IP EIGRP neighbor command will tell us the information about the neighbor adjacencies. As you can see over here, you will get an IPv4, the address of the neighbor in first column. Second column is telling that which local interface of your router on which you have given this command is connected to that particular router which have this address. Hold down timer. Now this is the timer of the time after the elapse of that time, the neighbor is declared as a dead or down. This uptime column is amount of time since neighbor is added to the neighbor table. So this command is actually telling us the contents, showing us the contents of neighbor table. For verification of our EIGRP routing protocol, helpful command is show IP protocols. And in show IP protocol, as you can see on the slide, it gives us the autonomous system number, which is important element of our routing. The other thing is the router ID. Now, if you look at this, we have given this router 1 as a router ID of 1.1.1.1. So it looks like an IPv4 address, but it is not an IPv4 address. The format of ID is like IPv4 address. In our lab, just to make things simple, R1 will have ID of 1.1.1.1, router 2 will have ID of 2.2.2.2, router 3 will have a 3.3. Just to make things simple. And then also, once we are looking at the routing table, the show IP EIGRP neighbor command, when you neighbors over there, it will help us to see and to identify our router. And then this show IP protocol command will tell you the networks which are added into with the help of network command. And if anything is missing, by looking at your topology, you can verify those networks. If they are not added, then of course you can use this command for verification purpose. And if those networks are not added, then you can go again back to router EIGRP autonomous system number 1 and then network command. Show IP route, that will be the verification of all your routes which are learned in this one. D is the code for EIGRP. All those routes which are learned with the help of EIGRP routing protocol, they are in the routing table, they are mentioned as D. And as you can see, and you already know, but just to review the concept, that this is the network which is learned by EIGRP 172.16.2.0. Then what this number is, Nani?
Distance.
Yes, administrative distance. Oh. And this is your big number, 2170112. It's a big number. It's a metric value cost of that link. I will explain later on that how we calculate. I will explain also, and we will learn that what is the full formula and how we calculate that. This is your next hop IP address 172.16.3.2 to get to that network. And then serial 00 interface is your local interface of the router, which will be used by this router to send that packet towards that destination network of 172.16.2.0/1. So all those routes which are learned through EIGRP, they are those lines in the routing table are mentioned with this D, D, D. Okay, so any question about configuration of EIGRP? The network command and the mode of routing protocol is the same as we've been doing in the OSPF. So let's talk about that how this EIGRP neighbor adjacencies are created. So we already know that there are there are 5 types of packets which are there in the EIGRP process. One is the hello. So first of all, hello is sent. So if you look at this topology, R1 and R2 is connected through Ethernet network, which is the simplest topology we can have. So R1, in a first step, R1 will send a hello. Hello is just like if a new neighbor settles in our next door. So what we do, just go there and they say hello, and then at the response he says hello as well. So it's just the same thing. So I'm just saying to the other router that hello, I am a router 1, okay, and are you there? It's just that message. And then in response to that, this router will also send a hello. So that is the start of neighbor adjacency. And after that, a update packet from the router 1 will go to router 2. Update packet will contain all the information of the networks which are connected to R1. It may have 3-4 LAN networks here, and then including that WAN link or LAN link, whatever it is. It will make a packet, update packet, information about that, and send across. And it will send to R2. R2 will receive, and then it will send its own update. So by sharing those updates, okay, they will create a topology table. Okay, and if there is any missing network, then this after sending those update packets, it will create a topology table. So first, after exchange of hello messages, it will create a neighbor table. So R1 will contain that I have a neighbor R2. In the neighbor table of R2, it will say that I have a neighbor R1. And after exchange of update messages or packets, they will create a topology table which have a list of all those networks which are known to R2, and R2 will contain all that information which is known to R1. And after that, what will happen? The dual algorithm will be run. And then in the dual algorithm, best routes will be selected from the topology table, because topology table will also contain best and second best. Best is written as, in EIGRP terminology, as a successor, and second best is called feasible successor, and successor will be promoted to routing table. So routing table will contain all those successors, but of course there is, and all the feasible successors. It may be multiple feasible successors, and we will discuss about that, how that feasible successor is chosen, because in order to become a feasible successor, it needs to fulfill a condition which is called feasibility condition. So we will discuss about that. So routing table will contain all the successors, all the best paths, and that's what the main objective of any routing protocol is. That to make that routing table, because this routing table will be used after that for the forwarding of those packets. So once this routing table is made by the routing protocol, what the router will do? It receives a packet, it will look at the IPv4 destination network in the header of IPv4 packet, and then it will start matching line by line. So it moves line by line. Longest match will be taken as a destination, and then that particular interface, exiting interface of local router, will be used to forward that packet and also next hop activities. Once all the routers have the correct and most up-to-date information about the network, then this state or this stage is called state of convergence. In other words, we can say it's a stable stage. So everybody know everything else. So any question up to this point? The configuration, how we configure it, and how this router discovery and topology table and routing table is made by EIGRP process, the main process of EIGRP. Any question about that? No? Okay.